Mechanical processing method. Abrasive flow. When the abrasive passes through the inside of the workpiece in the form of fluid, it can achieve functions such as deburring, flash removal, rounding, and polishing. It is often used in the fields of aerospace, textiles, hydraulics, and engines. Let's take a closer look at its workflow. For some workpieces with relatively simple structures, bidirectional abrasive flow is usually used. As shown in the figure, there is a fixture in the middle to fix the workpiece, and there is a piston above and below. Generally speaking, the abrasive will be filled in the lower cylinder. Under the action of external forces, usually hydraulic, the piston below moves upward, squeezing the abrasive through the channel of the workpiece and entering the upper cylinder. The surface of the channel is where the processing is required. After the lower piston reaches the top, the upper cylinder begins to repeat the process just now, allowing the abrasive to pass through the workpiece again. After several cycles, the grinding of the inside of the workpiece is completed. Of course, there are some special structures of the processing surface. At this time, it is necessary to use unidirectional abrasive flow, such as the engine intake manifold. After it is fixed, the piston next to it begins to squeeze the molding material so that the operation will have a workpiece with a smooth inner wall. Abrasive is equivalent to the tool of abrasive flow machining, which is composed of carriers, abrasives, and additives in a certain proportion. The hardness of abrasive is relatively high, including silicon carbide, aluminum oxide, corundum, EDC. The viscosity of the abrasive they form is different, and the purpose of processing is also different. For example, when the viscosity is low, the flow rate of the abrasive passing through the edge increases, which can quickly remove the burrs and flash on it. When the viscosity is high, the abrasive is close to solid, and it will form a shear state through the edge.